Hello, can you hear me?
Oh, yes, I can hear you. How are you?
I'm good. I'm good. Okay. Okay. So today we are going to cover these three areas, these 3 or 4 areas, right? We will start with linear programming, right? We will do one question and we will do few MCQs, 2 to 3 MCQs for it. And in case we have time, we can also cover an MTQ here. Then we will move to throughput costing because this is an important calculation, and I think students are not that much comfortable in throughput costing. So it's better to revise it. Then you'll take a break, and after that break, we will start risk and uncertainty. Sorry, risk and uncertainty. We will do um, maximax, maximum, minimax regret, and decision rules, right? And then at the end, we will do environmental management accounting, and we will revise environmental management accounting, and we will do around 6 to 7 MCQs. And I think those MCQs are important, right? So let's quickly start with this. Let's see what we can do here. Okay, so linear programming. Let me try to quickly recap about linear programming. That what is the concept of linear programming, what we do in it in 5 or 8 minutes, and then we will start with a question, right? So in linear programming, the best part is that we don't have to prepare any graph, but it's important. It's important for us to understand that graph preparation, we should know graph preparation, how graphs are prepared, right? Like for example, um, we generally start with a contribution equation, right? Where we write what is the contribution of X. Let's suppose $10 is the contribution of X and $20 is the contribution for Y. So we generally prepare a line, uh, an equation for contribution. Then we move to constraints. Constraints are generally for the restriction thing. Restriction in the sense that let's suppose someone says that, hey, look, labor, 2 hours of labor are required in the manufacturing of X and 5 hours are required in the manufacturing of Y. This is labor. And maximum labor time we have is around 15,000 hours. We don't have more than that, right? So how we will make the constraint? We will write 2 into X plus 5 into Y should be less than equals to 15,000, right? Same we will do with material. In material, we will say, okay, fine. Let's suppose material consumption is 4 kilograms for X and 3 kilograms for Y. So if that is the case, and if let's suppose maximum consumption is 12,000 kilograms, in that case we will write 4 kilograms used in the manufacturing of X, 3 kilograms used in the manufacturing of Y should be less than equals to 12,000, right? And then we generally make if there is any demand constraint, let's suppose the sales volume maximum sales volume of X is around let's suppose 6,000 units. You cannot manufacture more than 6,000 units of X, right? Or maybe 3,000 units, 4,000 units. So we'll say X should be sorry less than equals to 4,000, right? So generally we prepare these constraints. Constraint development is important because generally what examiner do is instead of giving you the constraint, examiner make a graph and then give you some equations. So it's important for you to understand what are these equations, right? And then what we do, we simply plot these equations in the graph. Graph, how you will plot these equations? Let me try to remind you. We say, okay, fine, this is the equation, so we are going to plot this line. So labor line can be plotted by keeping zeros for x and y's, right? So we say, okay, fine, if the equation is 2x plus 5y is equals to 15,000, so what if we put x is equals to 0? What will be the value of y? Y will be equals to 3,000. And if we put y is equals to 0, like if we make this 0, the value of x will be 7,500. So you say, okay, find x for x0, y should be equal to, let's suppose, 3,000. And for 0y, x should be equal to 7,500. That will come in on the x-axis. This is the x-axis, this is the y-axis, right? So we will plot a line like this, right? And we'll say that this is basically line of labor, which is 2x plus 5 mu should be less than equals to 15,000, right? So similarly, we will make another line for material. Let's suppose material line is this. I'm not plotting it because generally this is something which is given in the question. So material equation is 4x plus 3y should be less than equals to 12,000. And then there is a demand constraint that production should not exceed 7,500. So let's suppose this is a line for 7,500, right? So x should be less than equal to 7,500. So this is basically what this is basically. This will get closed. Okay. So this is basically the linear programming graph, right? These are the limitations. What do you mean by limitations? Limitations means that since all variables are less than constraint, less than equals to constraint, therefore feasible area of all constraint will be on the lower side, right? So if you produce any output on in section A, in region A, it is not going to be a good output because this will 2x is the line of labor. So since this is sorry, since this is above this labor line, that means at this region A, you will have enough quantity of material, but you will not have enough quantity of labor. Similarly, if you try to produce any output in region B, region B, sorry, pardon, I'm having a bad throat. So in region B, since this is less than labor line, so that means labor will be available. But since this is over and above material line, that means material will not be available. In simple terms, if this is a line for linear programming, if you choose any output in region A, it's possible. If you choose any output in region B, it's impossible. If you choose any output on this line, then what will happen on this line means that on these 4 points, the material or labor or whatever resource is that will be 100% consumed, right? Here there will be a surplus capacity and here this will be in shortfall. But on the line, consumption will be equals to availability, right? So this is generally how we prepare the graph, and then we identify the feasible area. In very easy terms, if all constraints are less than constraint, then the area which is right above the origin is supposed to be the feasible area. In this case, it is this, right? Because this is the area which is beneath all constraints, right? So we'll say that let's suppose this is A, this is point A, this is point B, this is point C, this is point D, and this is point E, right? I hope. Okay, just a second. I'm just, yeah. Okay. What happened? Yes, Shamira.
Good morning. Good morning.
Morning.
Kindly help me with the document we are using to do the questions. I can't find it.
Sorry?
Kindly help me with the document of the questions we are trying to do. I can't find it on the group and on the email.
No, these are not the questions which I'm doing. It's just an example. We haven't started any question yet. Okay?
Okay, thank you.
Don't worry, don't worry. Okay, so after making this graph, what we are supposed to do, we have two options. The first option is that if you can follow that. Okay, let's not do it like this. After that, we have to identify the feasible area. Now, how you will identify the feasible area? Feasible area we identified. Sorry. Now, what we are supposed to do? We are supposed to identify the solution. Solution is generally on the corners of the feasible area, right? How, so, what is the solution? B, C, D, or E? For that, there are two options. The first option is that you try to check all the options, calculate all the quadrants of B, C, D, E, and then put in contribution equation. It's a very long process. The second option is try to make this line in the graph. Generally, this line is examiner give you this line, right? So let's suppose if there is a line like this, right? This is a line, and generally this line is prepared by examiner. And in the examiner generally write C is equals to 10 plus 25. So what you are supposed to do, you are supposed to move this away from the origin. Actually, scale option is not available in on my tablet. So I'm just trying to, uh, yeah, we got this line. So now what you are supposed to do, it's something which is quite, I mean, if you do in the paper, it seems quite stupid, but uh, sometimes you have to do this thing. So you have to take a scale, right? Put it in the slope, in a similar slope as it for your question, like this slope and the slope of scale should be exactly same, right? And then you have to move it away from the origin. So the point which will remain at the end, right? The point which will remain at the end will be the best line, will be the best solution. So uh, B is, I mean, B is the first point which is cutting, right? Cutting or which is left. So it means that B out of all these points, B have the lowest profit, right? If you move away from the origin, the next point which will cut is either C or E. Since C and E are quite close, this means that the if you calculate actual profit at point C and E, profits will be extremely close. Like maybe one at point C you get a profit of 11,500 and at point E you get profit of 11,700. So there is just a difference of $200. So since the difference is quite close, it's almost impossible for you to identify which one has the higher profit, right? So in that case, generally we test both C and E if we are stuck with it. But fortunately, if you move away from the origin, away, the last point which is left is point D. So we will say point D is the solution, right? I'm repeating this. You have to put a scale on the slope of contribution equation. You cannot change the slope. You have to move away from the origin. The last point, which you get, is basically your solution. This is the simplest and easiest way to do, right? If your slope is like this, let's suppose your slope change, right? In that case, uh, you may get a wrong answer, right? So right now D is the solution, right? Right now D is the solution. So what we will do, we will try to identify what are the points for point D, right? And how we will identify points, what is the value of X and Y in point D? We have to, okay, this is something which will not cover the point, but still, at point D, what is the value of X? X, this is the value of X, whatever the value is. And technically this is the value of y, but instead of calculating it like this, we generally solve the equation. So let's suppose if C is the solution, C is made from 2 points, which the first line is L and the second line is material. So we will put these two equations and we solve these two equations in order to get the point, right? So that's basically how we come up with the solution, right? So let's try to do a question, right? And let's see what we can do here. And after that, if we have time, we will do MTQ also. Okay. So And again, this is a type of question which can easily examiner convert it into an MTQ. I will tell you I will tell you how. The following constraint has been formulated. The following constraints have been formulated and a graph representing the new production problem has drawn. So these are the constraints which have been populated. First constraint is Singa. What is this? We don't know, but it's quite a unique thing. Singa 0.25 into 0.5y is equals to should be less than equal to 12,000. This is what? This means that 0.25 kilogram, if let's suppose this is material, 0.25 kilograms are used in the manufacturing of X, zero point 0.5 kilograms are used in the manufacturing of Y, and the maximum material we have is 12,000. Same with beta, same with labor. And then we have two demand constraint. X should not exceed 20,000, Y should not exceed 15,000. And examiner has given you this graph. So the first thing which we can do, fortunately I have pen so we can do it. We should mark all these equations, right? So what is the equation of Singa? Singa equation is 0.25 of X plus 0.5 of Y should be less than equals to 12,000. It generally helps in doing the question. I mean, it's easier for you to if you can write these equations. 0.12y should be less than equals to 3000, and beta is 0.5 of x plus 0.2 of y should be less than equals to 3000, right? Cakes, this is the x-axis, right? This is the y-axis. So cakes should be less than equal to 20,000. So this is x should be less than equal to 20,000, this line. And this line is y should be less than equals to 15,000, right? So this is basically the graph, right? Now what is the first requirement? First requirement is quite simple. Explain. Explain what the line labeled C is equals to 0.26 of x plus 1.5y on the graph is, right? This is the first requirement. And what the area represented by the point A, B, C, D. Now, if this is for 4 marks, this can easily be converted into two multiple task questions. This will be the first question, this will be the second question, and for this question, I can give you 4 options, option A, B, C, and D, and you need to identify the best option, right? So can you locate where is C is equals to 2.6x plus 1.75y? That is this one. Let me try to mark it with a different color. This is this one. And this is representing what? This is representing the contribution function, right? So if someone says that what is line C 2.6 x plus 1.75 is representing, right? This is basically the contribution equation. This is basically equation for contribution, which is representing that contribution of x is cakes basically, right? So you can write cakes. Cakes is 2.6 of 2.6 and contribution of cookies is 1.75, right? So this is a simple explanation of what do you mean by this contribution equation. Or if you want to further explain it, you can say that this line is representing contribution which company can drive from the sales volume of cookies and cakes, right? So whenever you put the value of x and y in this equation, you can get the contribution, right? So this is a simple explanation, but I believe that the examiner will give you 4 points for it. You need to identify it, right? And what is the area represented by OABCD? Now, what is this area OABCD? This is point A, this is point B, this is point C, and this is point D, and this is probably O. So what is represented by this area? This area is showing the feasible area, right? And what do you mean by feasible area? Feasible area is basically represent an area where all constraints can be satisfied. Simple plain English, right? Feasible area represents an area where all constraints can be satisfied, and I think that's fine, right? So these are two marks. You can say that 2 marks for part A and 2 marks for part B. Then it says that explain how the optimum production plan will be found using the label C this and identify the optimum point from the graph. Now the examiner is saying explain how the optimum production plan will be found using the line labeled C is equals to 2.6 plus 1.75y. So you are not supposed to use the points, you are supposed to use the scale option, right? So let me try to do this by, yeah, okay. So let's bring our scale because examiner is saying that you have to use this line, right? You cannot go for that points option. Uh, okay, okay. So this is basically the slope of line almost, right? Now what we have to do, we have to move this away from the origin. If you move away from the origin, the first point which left behind is A, then probably D, then it's B, and at last we have point C, right? So point C is the solution. I'm repeating. First we kept this scale in this line and then we moved away from the origin. The last point which is left is point C. So we will say C is the feasible area. C is the solution, right? At the end, I will tell you if I'm not doing it via scale, what we can do, what else we can do. Okay, so point C is the solution, right? Point C is the solution. Let me mark with a different color. Okay, point C is the solution, right? How we found this point C? In order to identify the best point, contribution line is moved away from the origin, keeping the slope same. The point which is left at the end represent the best solution, right? Simple. Okay. Okay. So now they are asking and identify the optimum point from the graph. So we identify the optimum point is point C, right? Um, are they asking for solution? Explain how optimum production plan will be found using label C and identify the optimum point from the graph. I think we have to identify the point for point C, right? So if someone says that what are the values of x and y in point at this particular point, so how you can calculate the value of x and y? You have to understand which points, which lines are actually making this point. So there are two lines. Basically, the first line is of labor and the second line is of cakes, right? Labor and cakes are making this equation. So labor line is this 0.1x plus 0.12y. 0.1x plus 0.12y should be less than or equals to 12,000. No, 3,000. This is the equation of labor. And the second line is of this x, right? This is the second line which is for x. So we just need to write x should be less than equals to 20,000. So this is an easier option, right? So at this point, we just need to, because we know already the value of x, we just need to put the value of x in this equation in order to get the value of y. So 0.1 of 20,000 plus 0.12 of y should be equals to 3,000, right? So we need to have this split. Okay. Oops, sorry. Okay, it's not reducing by much. So this will be, okay, this will be 0.1 into 20,000 plus, okay, fine, 2,000, and 0.12y is equals to 3,000 minus 2,000 is 1,000 basically. And y will be equals to 1,000 divided by 8,333.32. Since examiner didn't say that you have to round it to a whole number, we will keep while we go to this one. And what will be the value of x? X will be equals to 20,000. So at this particular point of time, at this point, if we manufacture 20,000 units of x and 8,333 units of y, we will get the best solution. Right? Acha, next one is quite interesting. Next one, examiner is asking, explain what our slack value is. Explain what a slack value is and identify from the graph where slack will occur as a result of the optimum production plan. Right. So let me try to explain you what is slack in a separate discussion. Then we'll come back. See, let's suppose this is a graph, right? This is the first constraint, this is the second constraint, and let's suppose this is the third constraint, right? And let's suppose solution is at this point. Like this is the solution. This is the equation of material, this is the equation of labor, and this is the demand equation. So let's suppose that this is point A. So at point A, what will be slack and what will be the binding constraint? Let me explain you what is the slack and what is binding constraint. Slack means that you have extra quantity available, and binding constraint means that binding constraint means the resource which we are talking about is 100% utilized. Now let me try to explain it by using this graph. At point A is made up of two lines, demand line and material line. This means that at this particular point of time, material will be 100% utilized. Right? That means what? Okay. And what about labor? Since labor is there's a gap between labor line and this point, labor will be treated as slack. Right? Similarly, if we are talking about point B, then at point B, since point B is made up of material and labor, therefore in this case material and labor both are binding constraints. Right? There will be no slack in that case. And let's suppose the solution which you are getting is at point C. Point C is made up of what? Point C is basically y-axis and labor. So since material is still, we have this line is inside this material, therefore material is in slack and labor is binding constraint. Right. So this is the easiest way to identify slack. If Try to locate the solution and see at solution point which line is actually making the solution. So the line which is making the solution is binding constraint, is 100% utilized. And the line which is in the area which is above that line is actually your slack, right? So let's try to magnify this. Can you identify what is slack here? See, we have labor, beta, and sigma, right? So we know that this point is actually what this point is actually at labor and demand function. So at this point, labor will be the binding constraint. We will prove this also, right? And what about sigma and beta? Sigma line is this one. This is the line for sigma. And this line is above this solution. So sigma is in flat. Flat means surplus, right? What about beta? Beta is this line. Beta is slightly above the point. So beta is also in flat. So if someone asks you what do you mean by slack, slack means that at solution this resource will be available in extra quantity. Like that is that still we will be having some extra quantities of that raw material. In this case, since sigma and beta both are above the solution point, that means there will be a surplus capacity. And if you try to identify this by using equations, there is also a chance that you can do same thing by an equation. So what is the solution we got? Y this 833. Okay. Right now Y is 8,333.33 and X is 20,000. So the second option is if you don't want to do it via graph, what you can do, you can just simply put these X and Y in these equations, right? This part is showing the consumption now. So if consumption is less than 3,000, that means this is the slack. Let me try to do it. 0.5 of X, 0.5 into X is 20,000 and Y is 0.2 into Y is 8,333. The answer is 11,666.6. Means consumption will be 11,667 kilograms, which is definite. Have I written the correct equation? 0.5 into 12,000, sorry, 12,000. This one. So this 11,667 point, so this is 11,667, sorry, yeah, I did it wrong. So this is less than 12,500. That means if we produce 8,330 of Y and 20,000 of X, still we will have this beta. Let's try to do the same with sigma. Sigma is 12,000. Yeah, this is right. Okay. So let's try to do the same with this 0.25 of X, which is 20,000, plus 8,333.3 of Y, which is into 0.5. Okay. 0.25 into 20,000 plus 0.5 into 9160. Again, the consumption is less than 12,000. Still, that means if we produce the output, we will still have something left. What about this one? Let's try to prove this one as well. 0.1 into 20,000 plus 0.12 into 8333.33. See, it's almost 3000. So since labor hour consumption will be equals to almost 3000, that means at solution, the consumption will be exactly equal to the quantity available, and that means this is a binding constraint, right? Now, from here we can identify the concept of shadow price and shadow price, right? Shadow price means what? That we have prepared this whole thing, and that is not the part of this question, by the way. We have prepared everything, and now some labor comes to me and he said that, look, the problem is with labor. Now you have enough quantity of beta, you have enough quantity of singer. The only problem is with labor. I said yes. He said, okay, fine. We will work for you, right? And we will do the overtime, but you have to pay us. You have to pay us. Um, try to delete it. You have to pay us around $8 per hour extra, right? If you pay us $8 per hour extra, we will definitely work for you. Can you pay us $8 per hour extra? Now I'm thinking what to do. Because see, the simple idea is if I have benefit which is greater than $8, I will accept this proposal. If the benefit is less than $8, I will reject the proposal. And for that benefit, we need to calculate the shadow price. What is shadow price? Shadow price represents the benefit which we can have from one extra unit of binding constraint. Since this binding constraint is labor, so unit is number of hours, right? So for the calculation of shadow price, right? For the calculation of shadow price, what you can do is, I just saw that there's no calculation needed. That means everything which we had to do is by using the graph. Okay. Shadow price. For shadow price, you need to locate where is your solution. Solution is this one. Point C is the solution. No? This is the solution. And at this solution, there are two lines. X should be less than or equal to 20,000. And labor equation is 0.1 of X plus 0.12Y should be less than or equal to 12,000. Yeah. So how to calculate the shadow price of shadow price? You have to identify for which constraint you are trying to calculate the shadow price. Since we are calculating for labor, we just need to add 1 in the available hours, right? So now we will solve this equation by having this 12, instead of 12,000, we will see 12,001, right? So let's suppose labor equation is 0.1x plus 0.12y is equals to relative 12,001, right? So, and x will, the second equation will remain same. So just need to put x here, right? So 0.1 of 20,000 plus 0.12 of y is equals to 12,001, right? So this will be 0.1 of 20,000. It's 2,000 minus, what is, sorry, probably it's morning. Right. It was 3,000. We wrote wrong equation. So the next lesson is after writing the equation, try to verify that when we copy it correctly or not. So 0.12y will be equals to 1001. Right? So y will be equals to 8341.66. Okay. So at the new point, what is the value of x? X is 20,000. Y is 8341.6. And what was the original version? What is the older version? Older version was x was 20,000 and y was 8,333.3. So what will be the shadow price then? See, we generally compare x and y both. So change in x is 0. Change in y is minus 8341.66, right? It's 8.23 units. We will now manufacture 8.23 units more, right? Because this is the newer version and this is the older version. So newer version is having more units. And 1 unit contribution of 1 unit of y is 1.75. 14.58 is the shadow price, right? It means that if labor will work 1 hour extra, we can have a profit of extra contribution of 14.58. Now, let me try to remind something. Let's suppose that the wage rate of labor is $10 and labor is demanding extra overtime premium of $8. Labor is asking that over $10 you have to pay us $8 extra. Now, will you accept the offer? Will you accept the offer? Here, students generally do a mistake. What they do is they add these two figures and they say that the overtime rate is $18 per hour, like $10 normal and $8 we are paying him extra. So there are two options to compare. One, to compare 14 with 18. Second, to compare 14 with 8. Which one is correct? That's the question.
I think comparing 14 with 8.
Yes, comparing 14 with 8 is correct because 18 includes $10 and this $10 is actually the part of your regular contribution, right? So we have already considered this 10 in the regular contribution. We'll compare it with 8, right? So that means what? That means we should accept the offer. But if you compare 14.5 with 18, in that case, you will make a wrong decision because 18 is higher than 14. So you'll say no, cost is higher. We will not accept the offer. So technically, it should be compared with 8, yes, and it should not be compared with the total contribution, right? So let's try to identify this one, right? This is a simple MCQ. Can we do this? Um, a linear programming, right? A linear programming model has been formulated for two products X and Y. The objective function means contribution line, is depicted by the formula C is equals to 5x plus 6y, where C is the contribution, X is the number of product X, and Y is the number of product Y to be produced. Each unit of X uses 2 kilograms of Z and each unit of Y uses 3 kilograms of Z. The standard cost of material Z is $2 per kg. The shadow price of material Z has been worked out to be 2.8 per kilogram. Shadow price is 2.8, right? If an extra 20 kilograms of material becomes available at $2 per kilogram, what will be the maximum increase in contribution? Now, shadow price is 2.8, right? This is the shadow price, right? My question, how you will calculate 20 kilogram benefit, right? There are two options which generally students do. The first option is 20 multiplied by 2.8 or 20 multiplied by 2.8 minus this price. From both options, you will get something in which is a part of option. This will be equals to 2.8 times 20 is 56 and 0.8 times 20 is 16. So either B or C. No change cannot be the option. The option should be this one. Because we are not paying any extra amount for material Z in this case. If the question says that, hey, look, standard price of material Z is $2, but supplier agreed to pay to charge $2.5 per kilogram because the material is in short supply, and the shadow price is 2.8. Right? Now, what will be the benefit? So, since we are paying $0.5 extra to get the material, that means the benefit will be 2.8 minus 0.5. 0.5 is the extra amount, 2.3, and then we will multiply 2.3 with 20. So if you are paying any premium to the supplier, in that case, we will deduct that premium amount, not the price, premium amount. And then we calculate the final benefit, right? Or, so this is basically something which you must understand whenever you are doing such questions, right? Is it clear? I hope this is clear. This question I got, someone is saying something. Okay. Yes, Linda.
I'm a bit lost. If you can just start again.
The whole
Because I
MCQ.
was gonna, yes, this one, because I was gonna go for 16, increase of 16. So I'm a
No.
bit lost there.
No. Okay, fine. Let me tell you this thing. See, this $2, this is the standard price of material Z. Right? This is the standard price of material Z, which you have already included in your contribution calculation, right? Now, if the question is saying that, look, the shadow price is 2.8, this means that if you get extra quantity of raw material, you will have a benefit of 2.8 per kilogram, right? And in the calculation of this 2.8, we have already considered this $2. This $2 is the part of contribution. So that we have already considered. Important here is to understand, are we paying any extra amount? So if the question is saying that we can have this material at a price of $3 per kilogram, we have to pay supplier $3 per kilogram. That means extra amount which we are paying is 3 minus the normal price. $1 per kilogram we are paying extra. And if we pay $1 extra, we will have extra 2.8 per kilogram. So which means that the net benefit will be $1.8 per kilogram. Right? Or let me tell you this in another way. Let's suppose that we have calculated the shadow price. Let's forget about this question. Shadow price is around $5 per kilogram. and the normal price of raw material is $20 per kilogram. If I ask you how much premium the company will be willing to pay to suppliers. So the word is premium. Premium means extra, right? So how much extra company should be willing to pay to this company that is equal to the schedule price. Why? Because company will have $5 benefit from this raw material. It can pay extra $1, it can pay extra $2, it can pay extra $3. Even if it pay extra $4, still it can have a benefit of $1. But if it pay $5 extra to the company, to the suppliers, it will have no benefit. And if the supplier says that, hey, I want to charge $6 premium from you, that will not be acceptable. Okay. Shadow price or premium. Premium will be equal to shadow price in this case. Now, if the same examiner asks you how much calculate the maximum price which the company will be willing to pay to the supplier. So maximum price, how much maximum price you can pay? Maximum price you can pay is 25. So that means what? That means shadow price is actually representing the extra amount, right? The extra benefit which you can say, which you can get. So maximum how much extra you can pay? You can pay maximum extra amount which is equal to the shadow price. So if you pay $4 extra per kilogram to supplier, you will have a net benefit of $1. Similarly, the same thing can be said that if you pay $24 selling to a $24 price to the supplier, you can have $1 benefit from it. Right? I'm not sure if you got my point or not.
Yes, after this one, I understand now.
Okay. Now, let's have this question first, this MCQ first. This is an MCQ which I got from BTP and it's a good MCQ. I have included all BTP MCQs in majority of the BTP MCQs in KKDL platform, right? So you can access those MCQs from that as well. Almost I've uploaded. I mean those which are important and I think you should do. A company makes two types of products X and Y using the same type of labor. Labor production capacity is restricted to 50,000 labor hours per year. So labor is obviously SM3. The contribution per unit of 8 is for product X and 6 is for product Y. The following constraint apply to the production and sales. X is 10,000. 10,000 is the maximum limit for X. 12,000 is the maximum limit for Y, and 5X plus 4Y should be less than equal to 60,000. This is the labor constraint. The contribution maximizing output is 10,000 units of X and 25,000 units of Y. Right? This is the solution basically. Now, examiner didn't give you any graph. Instead, it has given you these few equations. You have to imagine the graph. right? What is the shadow price per labor hour? That means we have to calculate shadow price for labor. And how many additional hours of labor does the scheduled price per hour apply? Now, for the calculation of shadow price, you should have the solution point. We do have solution point, right? Then you have to identify which two lines are responsible for that solution point. Can we identify which two lines have made the solution? Let me try to identify how this graph Miles has prepared. Uh, X is 10,000, so this line will be like this. Y is 12,000, so this line could have been like this. And then there is a labor, right? There is a labor probably labor equation, like something like this. Now you need to identify for the shadow price which two lines we should solve along with labor hour. Like labor equation is 5x plus 4y should be less than equals to 60,000. Na? We need one more equation. So what should be that equation? X or y? That should be X. Why? Because the question is saying that the company has decided to produce 10,000 units of X. That means the line will be somehow the solution is will be at some point where X is equals to 10,000. Not like this, it should be like this. Because there is also a value of Y. It will be like here. Where X is equals to 10,000 maximum demand. This is actually intersecting at point X and then obviously the value of Y, value of labor. If the question says that Y is equals to 12,000, in that case, the best solution would have been this point, right? So since the solution says that X is equals to 10,000, that means one point has to be at this point. One point has to be on this line, right? I hope you got my point. And I'm assuming if you are not getting anything, you will ask. X should be less than equals to 10,000. Now for shadow price, you just need to add 1 here, right? So 5x plus 4y is equal to 60,001. So, and we will put x is equals to 10,000, right? What I'm doing, 5x. 5x plus 4y is equals to 60,001. So 50,000 minus 60,001. 4y is equals to 10,001 divided by 4. Sorry. 10,001 divided by 4 is 20,000, 2,500.25. So what will be the production? So initially we were manufacturing 10,000 units of X. We will manufacture same X because X is at the maximum capacity. If you produce more X, it's going to hurt you, right? Because you won't be able to sell it. So increase in X is 0. Increase in Y is 0.25 because initially we were manufacturing 2,500. Now we are manufacturing 2,500.25. So 0.25 into what is the contribution of Y? 6. 1.5. right? And in case there is a change in X, so we monitor that as well. So either option A or option B. Now the problem is the question has further identified that where you will, how many extra hours you will need for that. See, we have already manufactured X, right? So whatever labor hours will be available, we will use those labor hours for the manufacturing of Y, right? So how many units of Y we have manufactured already? 2,500. How many we have to manufacture? 12,000. So 12,000 minus 2,500, that means if we get labor, we can manufacture 9,500 units of Y. And how many hours are required for the manufacturing of 1 unit of Y? 4 hours. So we will need labor for 38,000 labor hours. For the next 38,000 labor hours, we can pay $1.5 extra, right? What if why this 47,500 is incorrect? Because once we manufactured product Y, we already have manufactured X. 38,000 hours will be required to manufacture Y. If labor comes and say that, hey, we are ready to work more hours, can you pay us extra? I will say no, because we have no production left. We have already manufactured X, we have already manufactured all of Y. So why to pay extra amount, right? I'm not sure how they concluded 47,500. Let's divide it with 4. No, not like that. Okay. So that's basically how we can calculate the shadow price and its related question. Now, this is a question for the theoretical part. You just take 2 minutes to identify the solution. It says 2. Shadow price are 2. True. If demand and labor hours are the constraints at the optimum solution, both will have a shadow price equals to 0. Do you think it's correct? If demand and labor are at the constraint at the optimum solution, demand means what? Demand means this line, and labor hour means this line, probably at this point. If demand and labor hours both are constrained at the optimum solution, both will have shadow price of 0. Do you think labor shadow price is 0 in this case? Labor is at solution. Whatever is at solution is the binding constraint, and binding constraint have a shadow price. Whatever is above the solution is in slack, and slack doesn't have shadow price. So since this is at solution, labor will have a shadow price. So this statement is false. What about the second? Try to read it and identify. Probably it's not correct. Sorry, you're saying something. Sorry.
Yes, I was gonna say it's the fact that they said the maximum amount, that's not correct.
Because this is representing the price. In material,
Yes.
this is representing the price. If it's labor, it's representing wage rate plus overtime, both, right? So probably it's not correct. Let's see what are the other options. If a resource has a shadow price greater than 0, means it has a shadow price. Obtaining one more unit, that resource will alter the optimum solution. If a resource has a shadow price greater than 0, that means its shadow price is somewhere 1, 2, 3, 4. Obtaining one more unit of that resource will alter the optimum solution. Do you think it's correct? Alter the solution means what? Alter the solution means that, let's suppose here it's 20,000 units of X and 40,000 units of Y, right? This is the solution. So if you have shadow price for more than one, it is saying that it may alter the solution. Like if you get the resource, you can change the solution. अगर हम if we get one more unit, if we get one more unit of labor, it will alter the optimum solution. Probably it's correct. Why? Because see, let me try to identify this. If we get one extra unit of the binding constraint, we can alter the solution because initially it was 2500, now it's 2500.25. Now solution is different, right? A resource that is critical to the optimum solution cannot have a shadow price, cannot have a zero shadow price. Critical to optimum solution means what? Critical to optimum solution means that is actually making the optimum solution. Cannot have a shadow price. Cannot have a zero shadow price, sorry. The point which is making the solution is binding constraint. And binding constraint have a shadow price. The point which is above the solution is slack. And slack has zero shadow price. So this is the correct one. Right. There's one MCQ. MCQ, we don't have enough time. I've identified that MCQ. I hope you can see this question. I will share this MTQ with you. This is a multiple task question, right? Where examiner has given you a graph. It has identified you which point represents the optimum production plan. Then you have to identify shadow price, and there are few questions related to the shadow price and everything. So I will share this with you. In case I forget, please do remind me and try to do it. This is a past paper question, so it will help you to further refine your concepts, right? So that's basically the linear programming. Now we are supposed to do throughput costing. Shall we take 5 minutes break or shall we continue?
Let's
Let's
continue.
first take a break.
I woke up at 4 a.m. today.
Maybe
For the
like 5
lecture.
a.m.
Okay, let's take a 5 minutes break. Let's recharge
Okay.
ourselves. Let me also get my glass of water. 5 minutes break, not
Okay.
more than that. We will come back for throughput costing. Right? Thank you. All right, I think we should start now. Okay, so now we are moving towards throughput accounting. This is something which is generally a problem for students if you consider all costing methods. So activity-based costing is generally not a problem. Life cycle costing is easy. Um, Activity-based costing, life cycle, target costing, these three things are generally easier versions for students. Students actually are not quite comfortable in throughput accounting as far as I know, as far as I got an experience. So let's quickly discuss the basic concepts of throughput accounting, throughput costing, and then we will move back. See, the most important thing to understand is why throughput accounting, why a company can be interested in using a throughput costing. The main idea is that if a company is highly automated and if you are manufacturing everything on machines, in that case, you generally labor don't work to produce the output. Labor in that case generally is doing something related on machinery, maybe inspecting something, maybe doing something. So generally, company pay them fixed wages, right? Fixed salaries. So in that case, what we say that it's better for you to apply throughput costing instead of marginal costing. So what is the main idea? Let me try to brush up the main ideas of throughput costing. In throughput costing, instead of calculating contribution, we calculate throughput per unit, and throughput per unit is calculated by generally deducting selling price with the material cost, taking the difference between these two. Why? Because we believe that the material is only thing which is variable. Everything else is fixed, right? Whether it's variable, whether it's labor cost, whether it's variable overhead, whether it's a fixed overhead. So basic problem is, see, there are three dimensions. Direct material is variable in throughput costing and in marginal costing both. Fixed overheads are fixed in throughput costing and marginal costing both. The gray area is actually with labor cost and variable overhead. These are uh, variable in marginal costing but fixed in throughput costing. And it's not the case that one company can use both. Generally, throughput costing is used, as I said, where mostly costs are fixed. We are paying fixed salaries to the labor, so it's better to use throughput instead of marginal costing, right? So that's basically instead of contribution, we calculate throughput per unit, right? Then whenever we are supposed to, let's suppose if there is a case of limiting factor, right? So if there is a case of limiting factor in marginal costing and in throughput costing, in marginal costing, what we do, we generally calculate contribution per limiting factor to identify the ranking. In throughput costing, we calculate return per factory hour, right? Contribution per limiting factor is contribution margin per unit over limiting factor per unit. Return per factory hour is, instead of contribution, we take throughput. So we say throughput per unit divided by throughput costing, we don't call limiting factor, we call bottleneck per unit, right? And if some product has high return per factory hour, we say that it's more beneficial. We will do it in a question right now. Then if someone says that whether to continue or discontinue the manufacturing of any product, if this decision, if someone asks you to take the decision, so in marginal costing, we say if contribution is negative, we should discontinue. In throughput costing, we say that if throughput accounting ratio is less than 1, then we should discontinue. If throughput accounting ratio is greater than 1, we should continue. And if it's equals to 1, we are indifferent. Indifferent means it's up to you. If you want to continue, you may. If you don't want to discontinue, if you want to discontinue, you may. There will be no benefit of continuing with that product. Now, what is throughput accounting ratio? And I think this is the most important one, because if someone really wants to check whether you know throughput accounting calculation, he or she should ask for throughput accounting ratio. This is return per factory hour divided by cost per factory hour, right? And how you will calculate return per factory hour? Return per factory hour is calculated by using this one. This is similar way of this is the same thing. Cost per factory hour is calculated by using total factory cost divided by total bottleneck time, right? So important thing is that return per factory hour is different for all products. And cost per factory hour is same for all products, right? So this means, so if return is more than cost, if benefit is more than cost, then your answer will be greater than 1, you should continue. If benefit is less than cost, your answer will be less than 1 and you should discontinue, right? So that's basically the theory of throughput costing, right? And if let's suppose that something comes, it can be asked in any situation where you are using marginal costing. The only thing which change is, instead of taking contribution, you will use throughput per unit, right? Like in linear programming, what we did right now, instead of using contribution equation, we will use throughput equation, and throughput equation will be throughput per unit for X and throughput per unit of Y. So instead of using contribution, you will use throughput, but don't get confused. Everything else will remain same. There will be no change, right? Okay. So now we are going to start with a very simple question, or shall we do the MCQ directly? This is a short question, and or shall we do the MCQ? In this part, we can revise everything. Let's quickly do this. What's the time now? 12:24. I think risk and uncertainty is left. I think we can quickly do this. In case something left, we can have one more session now. I mean, one session is on 10th. We can have one session of 1 hour maybe extra. We can do it. Complete. Okay. So what is the requirement? Requirement is to calculate Requirement is to calculate the throughput accounting ratio for device Z. Now, throughput accounting ratio is something which I personally believe that if you really want to check throughput, just ask for throughput accounting ratio. And then calculate the optimum production mix and profit per annum. That is the second requirement, right? So let's quickly move this. I will tell you how this same question can be asked in multiple task questions, right? Um, Beta company is company. Beta company is a company that manufactures three types of electronic devices known as X, Y, and Z. All devices are produced in a workshop using 5 steps process: circuit assembly, soldering, casing, quality inspection, and packing. The company goal is to maximize profit and is considering using throughput accounting to help to achieve this. The following information is available. Selling price of device X, Y, and Z all are given in this question, right? The only direct material cost for the devices for circuit board, casing, and packing, and these are all the material costs are given here for device X, device Y, device Z in all three processes. Beta company employs 4 workers, right? Each working a standard 40 hours week for 48 weeks a year. Their annual salaries are also given. There are just 4 employees who are working. The company general factory overheads, including rent, utilities, amount to 180 million per annum. The maximum annual demand for X, Y, and Z is 1,700 and 900 units respectively. The time spent by each worker on this device is as follows. Assembly technician worked, assembly technician, solder, inspector, packer, all hours are given here. The solder time has been identified as a bottleneck. So you are blessed in this question that examiner has identified what is the bottleneck time. Let's suppose if this part is not given in the question and in 122 marks question examiner asks you to identify the bottleneck activity. What you will do then? See, the only problem can be with these 4 because there is nothing else given in the question, right? So it can be assembly technician, it can be solder, it can be inspector, it can be packer, it can be anyone who can be the bottleneck, right? So if 2 marks question asks you to identify the bottleneck hours, how you will calculate this? You just need to compare required versus available, right? So available is generally given in the question. So in this case, the question says that there are 4 workers, each working a standard 40 hours week and for 48 weeks during the year. So 40 hours per week multiplied by 48 weeks is 1920 hours available for all, right? You just need to calculate the required, right? Let's try to do the first 2 and rest we don't need to do it, right? So let's start with this. 0.8 hours for device X multiplied by 1000 units of device X plus zero point 0.9 hours for device Y multiplied by 700 plus 900 multiplied by 0.5, 1880 versus 1920. We have excessive time. This is not a limiting factor. Let's try to check the second one, which is actually a limiting factor. 0.7 into 1000 plus 700 into zero point 0.8 plus zero point 0.9 into 900. It's 2070 hours are required versus available is 1920. So this is a limiting factor. So that's how we identify. If the question asks us to identify, we need to check all those scores and need to identify which one is the limiting factor, right? Now you have to calculate throughput accounting ratio. For throughput accounting ratio, just try to recall what we are supposed to do. For throughput accounting ratio for device Z only, right? So throughput accounting ratio is return per factory hour divided by cost per factory hour, right? Now we need to get return per factory hour for product Z only, right? So how we can get return per factory hour for material Z for product Z? Return per factory hour is throughput per unit divided by bottleneck hour. Throughput per unit for material Z. This is for X, this is for Y, and this is for Z. So 2800 is the selling price minus direct material is this one. 400 plus 200 is 600. And how many hours for solder's time required for Z? 0.9 hours. 2800 minus 600 divided by 0.9. Right? So return per factory hours 2444.44 divided by cost per factory hour. What is the fixed cost? The question is saying that the company general factory overhead including rent and utilities amount to 180,000 per month. So this is the fixed cost. Is this enough? No. We have to include the cost of these labor because labor is also a fixed cost in this case. So for cost per factory hour, 180,000 plus labor cost. Let's try to sum them up. 40 plus 35 plus 30 plus 28 is 133. Divided by total bottleneck time. Total bottleneck time is 1920. Right? So 180,000 plus 163. 14.99 is the throughput accounting ratio. So this throughput accounting ratio is suggesting that the company should manufacture the product, continue with the manufacturing, right? The next one is saying that calculate the optimum product mix and optimum product profit, right? How you will calculate the optimum production plan? For optimum production plan, we need to get the ranking. Now ranking can be done by both return per factory hour and throughput accounting ratio. But I think return per factory hour is an easier one. So let's try to calculate return per factory hour for X, Y, and Z, right? For Z, we already know that return per factory hour is this one. Let's quickly try to calculate it for X and Y, right? The selling price of X is 1500 minus this 250 plus 120 plus 15. 385 minus 1500 is 1115. Divided by bottleneck time is 0.7. 1592. This is for X. For Y, the same will be 2000 minus 300 minus 150 minus 18. 1532 divided by 0.8. 1915. So 1592, 1915. right? So the best option is to produce Z, then to produce Y, and in last we will produce X, right? So now we will prepare the production plan. Production plan is simple. We just have two 1920 hours, right? So first we will manufacture Z. We need to produce how many units? Demand. Yeah, this is the demand. We have to produce 900 units for Z, and 1 unit of Z require zero point 0.9 hours. 810. So we have 1920. Out of that, 810 will be utilized by Z. We are left with 1110, right? Next one is Y. We have to produce 700 units for Y, multiply by zero point 0.8, 560 minus 1110. We are left with 550, right? Now for X, it's 1000 times zero point 0.7. 700, of course, we cannot manufacture, we don't have 700, we just have 550 hours left. So 550 divided by zero point 0.7, 785. So this is actually the production plan which will maximize your profit, right? And if someone asks you to calculate the profit, how will you calculate? You'll multiply it with throughput per unit. Throughput per unit is this one, right? I'm not doing it, I'm just telling you. We have to multiply it with throughput per unit. In order to get the total throughput, right? And after getting the total throughput, we just need to deduct the fixed cost. Fixed cost is which one? Fixed cost is this one. This one, 180 plus 133. We just need to deduct that fixed cost, we will get the profit. Right? So that's basically how we can do this. 1920, yes. See, the question says that the company has, I'm trying to mark it with different color. The question says that the company employ 4 workers, each working a standard time of 40 hours for 48 weeks a year. So every worker is working 48 hours in a week. Sorry, every worker is working 40 hours per week, and we are working for 48 weeks in the whole year. So that means one worker cannot work more than 1920 hours. And since we have just one worker for each operation, that means we don't need to multiply it with the number of workers, right? Let's suppose that the question says that there are 5 assembly technicians. So in that case, this 1920 will be multiplied with 5 in order to get the total time, right? Okay, I hope I answered the question. Okay, now we are supposed to do some MCQs. Let's try to do a simple one. Not simple one. Try to read this MCQ and try to identify how we can calculate, how we can do this part. Read this MCQ, right? I'm giving you 2 to 3 minutes. Okay, can you guess how we can do this? Return per factory hour. For this, we need three things: selling price, direct material, and bottleneck per hour, right? Selling price is 40 per unit, material cost is 10 per unit, and a direct labor cost is 7 per unit. Direct labor cost per unit is given, but probably we will not deduct it. If the question asks you to do the same thing by using marginal costing, then we deduct 7. The total direct labor budget for the year is 50,000 labor hours at a cost of 12 per hour. Factory overhead, factory overhead are 2920 per year, right? The company is considering the introduction of system of throughput accounting. Is it has been identified that machine time is the bottleneck in production. Product X needs 0.01 machine hours per unit to produce. The maximum capacity of machine time is 4,000 hours per year. How you will calculate throughput? How you will calculate return per factory hour? I'm just giving you 30 seconds to think.
It's throughput per unit of a bottleneck.
Yes, so 40 is the selling price, right? We have to deduct material cost, which is 10. So this is throughput per unit, right? 30 is the throughput per unit. Divided by bottleneck hour. Now, bottleneck has been identified as machine time, and machine time is 0.01. So 30 divided by 0.01 will give you 3,000. This is return per factory hour. Now, cost per factory hour, how you will calculate cost per factory hour? Cost per factory hour requires total fixed cost. Factory fixed cost is 2920, but it does not include labor cost. We have to add labor cost. Here, this is something where students can do something wrong. They may forget to add labor cost. So you have to add labor cost because labor cost is fixed in throughput costing. How you will add labor cost? 50,000 labor time at a cost of 12 per hour. Don't consider this 7 because this 7 is per unit cost for product X. We need labor cost. Labor hours are given, so labor hours have to be multiplied with per hour time, right? So 12 multiplied by 50,000 is 600,000. Divided by maximum capacity of machine is 4,000, right? So 2920 plus 600 is 3520 divided by 4,000 is 880. This is cost per factory hour. 3.4. Right? Simple? Okay. Now this is another question. You have to identify which process is bottleneck, right? We have the product which we are manufacturing is passing through 4 processes: washing, filling, capping, and labeling, right? The following data refers to soft drink manufacturing company that passes its product through 4 processes and currently operating at optimal capacity. If you produce 1 dozen units, In washing, it requires 6 minutes. In filling, it requires 3 minutes. In capping, it requires 1.5 minutes. And in 2 minutes, label is done. Maximum machine hours are available. That is given here. Now you have to identify which process is bottleneck. If you have to identify which process is bottleneck, probably this is something which is completely irrelevant. You don't need to use this. But examiners generally give these type of extra information in the paper and the students somehow utilize it in some manner. I don't know what science they invent in the paper, they somehow utilize it. So don't use it. I'm giving you 2 minutes to think, not 2 minutes, 30, 40 seconds to think how you can calculate the bottleneck, which one is a bottleneck time. Because required compared with available cannot work here. Okay. See, bottleneck, the general definition of limiting factor or bottleneck is something that restricts your output, that will not let you to produce the complete output. So if you are producing a soft drink, technically it has to pass from all processes, right? Let's suppose, let's suppose that filling, let's suppose from washing, you can manufacture 1000 units bottles. Capping process can produce 2500 bottles. Labeling you can do 1500. But in filling you can only do eight. You can fill only 800 bottles. These are the capacity. So which factor, which process is actually limiting your output? Filling, because you can only fill 800 bottles. So even if you wash 1000 bottles, you don't have material to fill it. So if you will not fill it, you cannot produce the output. So actually the bottleneck in whole case is filling. So now what we are supposed to do is we are supposed to calculate the output which each process can produce. Like in this case, 1200 divided by 6 minutes, 6 divided by 60 will give you, this will give you 12,000. Like 6 divided by 60 is 0.1 hour. Na? So we are dividing it with 0 point, with number of hours. You can also divide it with minutes. I think, no. We cannot do this. This is in hours. So we have to divide it with hours. So this will be 12,000, right? 700 divided by 3 by 60 is 14,000. 250 divided by 1.5 divided by 60. 10,000. And in labeling, it's 13,500. Right? So which process has a problem? Capping. You won't be able to cap your product if you are manufacturing it. If someone asks you that what you want to improve your product, improve your output, my answer will be I need a machine in the capping division, or I need a machine for process of capping. Because if capping increases, it will increase my overall output because we have enough time for washing, filling and labeling, right? So that means capping is the answer. Now, there was a question which examiner asked in performance management paper. It says that it says two things. This is a question which examiner asked in an MCQ. You have to tell me whether it will improve the throughput accounting ratio or okay, let's see what we can write. Let's suppose I improve the efficiency. No, no, it's okay. Let's suppose I reduce idle time hours of filling department. Do you think it will solve the problem? No. Because if idle time will reduce, filling department will have more time, more productive time. Problem is not with filling. Problem is with capping. So if you reduce idle time of capping division, it will increase the output, right? Similarly, if you increase the efficiency of filling employee, do you think it will improve throughput accounting ratio? No, because throughput accounting ratio is based on capping. Capping is the limiting factor. So if you improve the efficiency of filling department, employee of finishing department is now more efficient. It doesn't make any difference to throughput accounting ratio. It doesn't make any difference to the output. But if you improve the efficiency of capping division or capping process, it will improve throughput accounting ratio and it will also improve probably the output of the capping division because in that case you will produce the same output maybe 1.2 minutes or 1.1 minutes. That's how we increase the efficiency. No? Similarly, there are some times where examiner asks in theory, examiner asks how you will improve throughput accounting ratio. So how you can improve, let me try to go back to this one. I think we can do it here. If examiner says that you have to increase throughput accounting ratio, throughput accounting ratio can be increased by either increasing the return per factory hour or reducing the cost per factory hour. How you will increase cost per factory hour? If you increase throughput per unit, you will increase return per factory hour. How can you improve throughput per unit? Either you increase the selling price or you reduce the direct material. If you increase selling price, throughput per unit will increase, return per factory hour will increase, and throughput accounting ratio will increase. If you reduce direct material, it will increase throughput per unit, it will increase return per factory hour, and it will increase throughput accounting ratio. If you reduce the selling price, if you reduce the selling price, it will reduce the throughput per unit, it will reduce return per factory hour, and ultimately it will reduce throughput accounting ratio. If you increase idle time hours, sorry, if you reduce idle time hours of bottleneck department, right? If you increase the idle time, it will, oh, I written it in a wrong area. Sorry. It's this one. If you reduce the idle time hours, it will increase the time available on key resource. If it increase the time available for key resource, your cost per factory hour will reduce. And when your cost per factory hour will reduce, it will increase your throughput accounting ratio. So this is something which you need to understand that what is going to create what impact on throughput accounting ratio. This is also something which is generally asked in the examination, right? So that's I think the end of throughput costing. Now I am moving to environmental management accounting, and then we will do the risk and uncertainty part because we already did a lot of calculations and everything. So let's do some theoretical things, right? Easier, we can do it in 15-20 minutes. Okay. See, environmental cost is in performance management, which is F5, and environmental management costing is in APM as well, which is the extension advanced version of F5. I think that examiner has more options to examine environmental management cost in APM because their examiner has lot. If the examiner can connect environmental cost with lot of things, ethical issues, SWOT analysis, there's a lot of topics there. In F5, the problem is that you guys are not mature enough. I mean, you guys are mature, but in terms of theory, you guys are not that mature to answer scenario-based question of environmental accounting, right? So examiner generally ask the basic things from students, but generally it's asked in MCQs, not in section C. Multiple task question in maybe one or two MCQs, right? So let's try to quickly go through over it. Let's try to quickly consider what is environmental cost and how what are the main areas. Okay, so the first point is why environmental cost is important. So I have taken all these things from an article, ACC article, which examiner published. That is in APM and PM both. Um, Now it's quite prominent. Environmental issues are quite prominent. At the time when it first released, this topic has been introduced in performance management. This topic was not that much big. The examiner gave us a lot of directions that how we can do this. Now people know about climate change, people know about sustainability issues, people know about all these things. So it's not something which the students are not aware about, right? Aware of, sorry. So let's start with this. Why management environment cost is important, right? Why do we need that? The first important thing is that people are more aware about it. If my company is producing something, it depends upon the developing and developed countries also. But if people are concerned about the environment, in that case, maybe people are not ready to buy your product because you are not producing in a healthy in a healthy conditions, right? So that is a problem number one. The second problem is that environmental costs are becoming huge for companies. Not particularly penalties, but the general environmental costs. Like your customer may want you to produce a product by considering environmental factors in mind. There was also a quality standard, I think 14,000 or 7,000. There is a quality standard ISO certification which require you to follow certain quality practices. So let's suppose your supplier is saying, your customer is saying that we will only buy the products from suppliers which are meeting the quality, which are meeting the environmental regulations and everything. So obviously you have the extra cost. This is something which actually in Pakistan is basically an exporter for footballs in FIFA. So that is a condition which I think they impose on the football association that you have to produce your whatever products you are producing, you have to go for certain environmental checks. So obviously you have to, you have to get those certifications done. So that's basically a huge cost. And then obviously the regulation, the penalties which the government is imposing are high. So that's the third reason why you should be concerned about environmental costs, right? Now, there is a research which has been made by Hessen and Mendoza, and they said that the most important thing is why there is an environmental cost because you are producing the waste. If you are producing the waste, then you have to be very particular about the cost which these wastages are bringing. Like let's suppose you are having a chemical waste or maybe a product waste or maybe anything like carbon. You are polluting carbon dioxide, you are emitting carbon dioxide. So there are a lot of things, there are lots of wastage which you are producing. So if you are producing the wastage, you have to bear the consequences. So they say that the quality is something which is the most important thing. Wastage is something which is actually creating the problem. So they have connected this environmental cost with total quality management. If you remember total quality management, there are four costs associated with it. Prevention cost, cost required to prevent the losses, appraisal cost, inspection cost, what we say, internal failure, and external failure, right? So these are generally four costs which are associated with the identification of cost, right? So environmental prevention cost means what? Prevention cost means all the costs which are necessary to prevent the losses to happen. Like you are trying to use a machinery which is not producing wastage, you are trying to use a material which is good enough, not producing the wastage. You are trying to have those systems in place which will reduce the wastage production. So the cost of activities undertaking to prevent the production of wastage is basically the prevention cost. This should be done by every company, right? But let's suppose that if you have produced, if you obviously you said that okay, fine, you cannot 100% be waste free. There will be some wastage. So the kind of wastage you are producing, you need to detect that. What sort of waste is that? How much wastage you are producing? Is this within limit? Is this crossing limit, right? So the cost incurred to ensure that the organization complies with regulation and voluntary standards, that is something which is need to be considered, that whether you are breaching the minimum requirement, maximum limit or not. Then environmental internal failure cause. Now what is this? Let's suppose you produce a wastage, you produce some uh, polluted chemical, you produce some polluted water or maybe some chemical which has a poisonous thing or something which is dangerous for the environment. So if you have produced something, some wastage, you have to neutralize it. Neutralize in the sense that you have to remove its dangerous or poisonous or harmful elements from that material first before discharging it to the environment. Before discharging it to the sea water or maybe before dumping it anywhere, you have to make sure that whatever you are discharging is not going to harm the environment, because if it will, you have to bear the consequences. So the cost incurred from performing activities that have produced contaminations and wastage that have not been discharged into the environment. Before charging to the environment, whatever you are doing is basically comes under the heading of internal failure cost. External failure means what? Now you have discharged some output in disposed some output in the environment, and now you have figured out that this is it's going to pollute the environment. Now what will happen? There will be a government, there can be a government penalty, there will be some social pressures on you. Maybe people will boycott you. So there will be a lot of consequences because of that. So all the consequences, all the costs which company will bear after discharging, as a result of discharging it in the environment, is basically environmental external failure cost. Cost incurred on activities performed after discharging waste into the environment, that is the external failure cost, right? So let's try to identify few things if we can do here. No, what is that? Yeah. So these are few examples. You have to identify these examples actually belongs to which part. There are four. I mean, we should do it as we are discussing the scenario. So there is prevention cost. Prevention cost, environmental prevention cost means cost required to prevent the losses to occur, right? Then there is appraisal cost or detection cost. Then internal failure cost. Internal failure means environment internal failure means that you have produced the bad output. Now you don't want to discharge it to the environment before. doing some procedures. So the cost of neutralizing it is internal failure cost. Then environmental external failure cost. Right? So you are supposed to identify the internal failure cost, right? I'm giving you, okay, fine. Let's read it and let's try to identify. After every point, I will take a pause of 10 minutes, 10 seconds so that you can try to identify these, right? Quality control inspections to monitor the pollution level in water leaving a production process. This cost belongs to which part? Quality control inspections to monitor the pollution level in water leaving a production process. This is appraisal.
I think it's oh sorry. Yeah, I was gonna say detection cost.
Which one? Prevention?
Detection cost.
Oh, detection cost. Okay, fine. Say. Okay. Water pollution, water purification treatment to clean waste. Oh, sorry, this is, I think these are two words. To clean wastewater before it leaves the factory.
Internal failure cost.
This is the internal failure cost. Why? Because you have produced the bad product. You have produced the bad product, now you want to purify it. If you are making any procedure which will help you to the prevention of the production of wastewater, that will go under the prevention cost, right? Fitting of a carbon filter to the machine processes to reduce carbon emissions. This is
Prevention cost.
prevention cost. Power usage measuring system to monitor energy consumption within the factory.
Detection.
Payment of fines for breaching environmental regulations. Purely external. Why? Because fines can generally be implemented when you did something wrong. So you have breached probably the regulations. That's how this external concept is. Insulation of heating. This is the sixth one. Insulation of heating pipes in the factory to reduce heat loss.
Prevention cost.
Public relation cost to remedy reputational damage caused by accidental river pollution.
External.
Capturing and recycling waste exhaust gases to generate energy. Capturing and recycling waste exhaust gases to generate energy. We are recycling it. That means a loss has been produced, wastage has been produced, but we are trying to recycle it so that we can reduce the damage. So
Prevention.
no, this will go internal failure
Mm,
because we are trying to recycle waste now. So recycling waste means that the loss has occurred, the wastage has occurred. Now you are recycling it in order to control the damage. So prevention cost would have been occurred if there was a reduction in the gases, wasteful gases. Right. Now the wasteful gases has occurred. Now we are trying to recycle it. So that comes internal failure. So that's basically how we can identify these cause, that what is internal failure, what is external failure. The best part is to spend lot on prevention cost, because if you are trying to have effective preventive measures, it will reduce the other cost because you don't need to have a controlling system. You will not have any issues with waste, so you will not bear internal failure, you will not bear external failure. The best idea is to spend a lot of money on environmental cost. I think there was one more MCQ here. Mm, yeah, this one. This is external environmental cost. External failure cost, I mean. Which one of the following belongs to external failure cost? These are three costs, right? The first one is, sorry, which of the following should be categorized as an external environmental failure caused by an airline company? Compensation payments to residents living close to airports for noise pollution caused by their aircrafts. Is this external failure cost?
Yes.
Yes. Because you have damaged the environment, now you are trying to control the damages, right? Air pollution due to the airline carbon dioxide emission from aircraft engine.
Yes.
Because if you spend money on the fact that you're trying to reduce the carbon dioxide emission, that will come under prevention. If you have installed a device which will measure the carbon dioxide which is emitting in the environment, that is the detection, right? And internal failure is quite unlikely in this case. There will be external failure. Penalties paid by the airline to the government for violating environmental regulations.
External.
No, yes, we are paying penalties because uh, we have we have made an output of so much gases. Now, generally, there is a problem with the students. I don't know why. Generally, students don't believe in two options. One, none of the above, and all of the above. They generally, I don't know why this is a psyche, but students believe that none of the above options cannot be the option, and all of the above options cannot be the option somehow. So, if the question says all of the above, generally students don't take here because they said no, there will be one factor which will not be there. So don't consider this, right? Don't think that this is correct. All three options are correct. Now, let's quickly move to this part. Okay. Now there are four costs which examiner has identified, which they have identified as an environmental cost, right? The first one is conventional cost. Conventional cost is the typical cost of raw material, material cost, energy cost. You are spending on water, chemical, like typical resource cost, right? Potentially hidden costs are the costs which are normal loss is a good example of it. Potentially hidden costs are like costs which are incurring in your company, but you are unable to identify it and you are unable to, mm, you are not distributing it among all products. Like normal loss. Normal loss means what? Normal loss means that you are producing losses, right? But ac- account on the base, I mean, by using accounting, you have made a solution that you will ultimately charge normal losses from customer, right? And normal losses are generally not reported in profit and loss account. So that means what if wastage is produced, you are allocating cost of wastage to the normal product and somehow you are losing the identity that where how much cost we are producing on wastage and how to improve that. Contingent cost is the cost, future cost. Like for example, if you are in if you are like for example, if there is an oil drilling company which drill and take out the oil, explore the oil. So what the company will do is company will go and takes out the oil. And let's suppose and we know that after 5 years of life, probably we have to clean this area, and probably we have to do some plantation or do something with we have to actually mm, correct the damage which we did to the environment. So that is basically kind of future cost, which is basically the contingent cost. Image and leadership cost, this is basically the cost which company has to bear in order to improve its image in the eyes of the customer. The best example right now is the integrated reporting. Now financial reports are published on an integrated basis, not only financial accounts, but you have to also report the environmental, the SDG things, the sustainability things in your report. So that's basically the stronger your SDGs are, the stronger your sustainability report is, the more you are good in eyes of the customer. So that is the cost which the company needs to get. So these are four costs which they believe that are generally if you see the accounting, so these are the four accounting costs, right? And then how you are going to improve the accounting of how you are going to manage the cost, right? So the cost management, how you are going to manage the cost, there are four ways how you can do this. The first one is activity-based costing. Now keep one thing in your mind that activity-based costing is always done for overheads, right? Activity-based cost is always for the overhead. So we need to study the overheads, and we need to identify if we can identify any cost which is associated with the environment. So if we figured out any cost which is related to the environment, we cannot distribute it on the basis of machine hours or labor hours. We have to identify a environment related cost driver, maybe the number of units you are producing, maybe the number of waste you are producing, or the maybe anything which is relevant to that activity, and distribute the overhead on the basis of that activity. So that's the activity based costing. Life cycle costing means that you have to identify all costs which are associated with the product, including the environmental cost, like the cleanup cost which we just read here. The cleanup cost, where it was, mm, this one. The cleanup cost, you have to identify this cost, and you have to include it in the calculation of the cost per unit of the product when you are calculating that. Now, input and output and outflow analysis means what? You have to attach some cost to the losses. Like, for example, you made an input of 100 kilograms, you got an output of 50 kilograms, so there is a loss of 20 kilograms. So what the company do is company generally say that, okay, fine, 20% is the normal loss, so we will include it in the calculation of cost per unit. Inflow outflow analysis says that no, you have to attach a cost for this 20 kilograms, and you must report this 20 kilograms separately in your profit and loss account, so that the stakeholder can understand that how much waste you are producing and what is the cost associated with that wastage. They don't consider the normal loss. It's something else. You have to report it. Because when you will report this 20 kilograms in the P&L, you will feel bad. And when you will feel bad about something, then you will try to do something to reduce it, right? So how you will allocate cost, because activity-based costing is simple. Examiner will give you setup cost or maybe supplier cost, maybe three costs, and then one head will be for activity-based, oh sorry, environmental cost associated with an environmental-based driver. You need to calculate OER and then multiply it as you are doing in normal circumstances. Life cycle costing is also something which will be given to you in your situation, in your question. Input output analysis is something where we need to attach some value, right? And now let's try to understand how we can do this, how we can attach the cost. Oh, sorry. Mm. Okay, so this is the cost, right? Let's try to understand how this cost can be identified. A company manufactures a single product, the root, which is made from the mix of two chemicals A and B. The company accounts for environmental costs using input-output analysis. Chemical A costs 1,000 per ton and chemical B costs 1,500 per ton. Any chemicals that are wasted in the production process must be disposed of at a cost of 225 per ton. So must be disposed of at a cost means what? Cost means that you are not selling it, you are incurring more cost in that. Maybe to neutralize the material. June's production run used 10 tons of chemical A and 50 tons of chemical B. The total output of root was 54 tons. We input 10 tons of chemical A. We input 50 tons of chemical B, this one. And so the total input is 60 tons. But how much output we got? 54. So what is the loss? Loss is of 6 tons. So this concept says that you have to add value to this 6 tons. Right? How you will add value to this 6 tons? Okay, let's try to do this. Chemical A cost is 1,000 per ton, $1,000 per ton. Be 10,000. Chemical B cost is $1,500 per ton. Okay, 50 into 1,500. Right? So 85,000 is the overall cost for 60 tons, right? But 6 tons were lost, right? So let's try to calculate what is the cost can be associated with 6 tons. So divided by 60 multiplied by 6. Not tons, sorry. $8,500, right? Is this the answer? No. This is given in the options, but this is not the answer. For these 6 tons, you further have to spend 250 per ton extra cost because you want to neutralize it. So there is an extra cost involved in this. So 6 multiplied by 10,000. So 10,000 is the answer. Option D. Right? So that's basically how we can attach cost. And if you are saying in your P&L that 10,000, the company lost $10,000 because company couldn't produce 100%, couldn't convert 100% input to the output. That means people will ask that what steps you are taking to reduce it. And then you have to answer. And then you will try to think how to reduce that. Right? Okay. And then the flow cost accounting. Flow cost accounting is basically they basically try to identify the physical quantities involved, right? Physical quantities involved. Physical quantities in the sense you need to identify that at which process, how much material you are adding, and at what processes, at what stages you are having your losses. And then if you want, you can add value to it, that how much loss is actually, like let's suppose there is a processing step, there is a mixing step, there is a packing step. So processing step, 0.1% material is lost, so you need to add the value in a similar way what we did, right? That's basically the concept of flow cost accounting. So this is basically the basic introduction of environmental management accounting. I think we can do one or two MCQ more and then we will finish. Mm, I think we can do this question, this MCQ. This is the last thing which we are doing, and then we'll see if we can do decision making a little bit now. A company manufactures cements. It has decided to improve its image with regard to environmental issues and is hoping that the new activity-based costing approach being introduced will help the company to better allocate environmental costs incurred. Right? Okay. Which two of the following environmental costs would be better allocated as a result of introduction of ABC? Normal material losses arising from wasteful manufacturing process, salary cost of supervisor at the company's carbon dioxide emission purification process, off-site cost of training staff to follow relevant environmental safety procedures when making products, increase hourly wages paid to compensate staff for working with toxic gases. Yes. Now let's start with the fourth one. Do you think it can be the answer? See, the problem is everything is related to environment. Everything is related to environment. This cannot be the answer. Why? Because this is related to the direct cost of worker. I said earlier that activity-based costing is something related to the overhead, not the direct cost, right? So this cannot be the option because this is something which is related to direct cost. Off-site cost, off-site cost of training staff to follow relevant environmental safety procedure when making the products. Training staff cost, training cost. So cost of training staff. So training cost is generally treated as an overhead. So this can be dealt in ABC. Salary cost of supervisor at the company's carbon dioxide emission purification process. Salary of supervisor. Supervisor is generally the part of overhead. So this can also be dealt with under ABC. Normal material losses arising from a wasteful manufacturing process. This is basically something which is treated as cost of production. So even if you are having ABC, you cannot make sure that you are distributing it properly because normal loss will occur, right? So I think this is a tricky one because if you miss this overhead part, you will probably miss this question, right? Okay, so now we are moving towards risk and uncertainty. Mm, I think we can do some MCQs of decision tree and we will finish today's session because we won't be able to do maximax, maximin and minimax regret because we don't have enough time and probably the energy. So let's start with decision tree, right? Let's see what we can do with decision tree. Let me try to do a quick recap of decision tree. Decision tree is generally applied in a situation when we have multiple steps, and in multiple steps we have multiple decisions and multiple uh, probabilities. Initially, when F5 started, generally when they were manual papers, the students were supposed to make the decision tree. Now students are not required to make the decision tree, but they should have a basic understanding of decision tree so that they can calculate the solution, the optimum solution, right? So let's try to have a basic idea for this. Let's suppose we are talking about uh, let's suppose we are talking about a product, right? We want to identify, or we are talking about a machine, and we are thinking whether to buy a new machine or continue with current machine. So by the way, there are two symbols. This one is for decision making, this is for probability. So initially we start with a decision or to continue with current situation. If we buy the new machinery, the cost will be around 400,000, right? And 100,000. And the output can be increased to 10,000 and the output can be increased to 12,000. There are 20% chances that output will be 10,000. There are 80% chances that the output will be 12,000. If we continue with the machinery, then we have two options. The first one is to modify. We can modify and we can continue same. If we modify, then output can increase to 10,000 and output can increase to 8,000. And if we continue with the same machinery, then the output can be around 6,000 and the output can be 5,000, right? Modification cost is around 50,000. And the contribution in all cases is $10, just to make it bit easier. If we modify, then there are 70% chances that output will be 10,000, 30% chance that output will be 8,000. In this case, there are 50-50% chance, right? So that's basically how we prepare the decision tree, right? We read the situation, we understand what we are supposed to do, and we make the branches, right? Then we have to solve this. Solving means we can start with any branch, right? We can start with this one, let's suppose, or we can start with D. Let's start with D first. Since D is with a circle, that means it's a probability, so we have to solve it with expected value. So let's try to do it uh, on calculator directly. So there are 70% chances that output will be 10,000 and then there are 30% chances that the output will be around 8,000. So the output at point D will be around 9,400, right? And the contribution is $10. So there are chances that the overall benefit will be 94,000 at this point, right? Since 50,000 is before that point, you are not supposed to deduct this. At point E, again there is a probability. 50% of 6,000 is 3,000, 50% of 5,000 is 2,500. So 2,500 plus 3,000 is 5,500 times 50 times 10, 55,000, right? Now, at point C, because we are done with this part, now we are moving towards point C. No, this one. Now we are moving to point C. Point C is a decision because that is in circuit, that is in a square. If you modify, you will have a contribution of 94,000, but for that you have to spend 50,000. You will have a benefit of 44,000. Or if you continue with same situation, you're not going to do anything, you will have a benefit of 55,000. So clearly you should continue with same. right? Now we cannot solve A unless and until we are done with B. So let's try to solve B. 10,000, 20% is 2,000 plus 12,000 into 8.8 is 11,600, right? 116,000. Let's reduce this cost to um, 60,000, 70,000. This is too much. So at point A, how you will take the decision? At point A, the first option is to buy new machinery. If you buy the new machinery, the benefit will be around 116,000. But for 116,000, you have to spend 70,000 for machinery. There are students who generally argue here that why we are considering the overall cost as it is. Technically, we should not have taken this whole cost in a single year, like 70,000. But if nothing is given in the question, we believe that this machinery will last for 1 year. But technically, there should be something given here. $46,000. Or continue with the same machinery. Continuation will give you around 55,000 benefits. The better option is to go to continue. So that means what the company should do, continue with, company should not buy new machinery, company should continue with the same machinery and in the same condition without modification. That should be the answer, right? Now let's try to have some MCQs for this. Let's try to do this first, right? The requirement is quite simple. What is the maximum expected profit at point Z? Point Z is what? Point Z is this one, right? So you have to identify something which is at point Z, right? So let's try to consider point Z. There are two branches of point Z. So first we have to solve this one, right? We have to get a point at this one and then we will compare it with the second one, right? So at point 1, or you can say A, there are 80% chances that the profit will be 40 million. There are 20% chances that profit will be 20 million, right? There are 40% chances that the profit will be 80 million and there are 20% chances that the profit will be 20 million. So the answer is 36. Right? Now we can solve Z, but so Z is actually a decision. If we continue, we will get a benefit of 36 million. But if we continue, we have to bear a cost of 32 million also, because that is a negative. So that will give us benefit of 4 million. The second option is we don't continue, we should abandon it. If we abandon it, the benefit will be 2 million. So clearly what we will decide to go for it for 4 million, continue. So answer will be 4 million, right? If question says that, let's suppose this is point Q, right? This is option Q. And if the question says that, hey, solve for point Q, what you will do then? For point Q, at point Z, we have taken a decision to continue and the benefit will be 4 million. So 60% chances are there that the profit will be 4 million, and there are 40% chances that the profit will be 1 million. So 60 into 4 plus 40 in 40% of 1, that will be equal to 2.8. This is the answer at point Q. We cannot proceed to this option because we don't have anything from P and Q, so we cannot proceed with that. So that's how we can do it. One last question and then we'll finish. I want you guys to solve for this question. I'm giving you 2 minutes. Think how you can identify this initial cost. Read this part. This is important. Take 2 minutes and then we will see. All right. See, there are point A, point B, and point C. At point B, what is the answer? There are 80% chances that it will be 2 million, and there are 20% chances that this will be 1 million, right? So here it's 1800. What about C? 2000 times 70% plus 1000 times 30%. 1700, right? Okay. The question is actually asking you that, let's suppose that company wants to, what would be the cost of the upgradation, this point? That would make the company financially indifferent between building a new premises and upgrading the older one. So we are trying to get an option where both decisions will have the same value, right? So let's try to move for this one first. If you build a new premises at point A, if you build new premises, you will get a benefit of 1800 and you will have to bear a cost of 1 million. That means you will have a benefit of 800 in the first part, right? Now financially you will be indifferent if you have both 800 in both cases. What is the second option? Second option is we will have the benefit of 1700, right? How much should be the upgradation cost that we will have the benefit of 800? Because we are not sure, this is the cost now. This is the cost. In the second case, we don't know what is the cost, but we want to be indifferent. Indifferent means the answer of both options should be equal to, should be same. So what should I deduct from 1700 to get 800? Simply 1700 minus 800 is 900. So if your upgradation cost is 900, you will be indifferent between choosing in option A and option B. So that would be option this one. All right. So that's basically how we can do the decision fee part, right? This is something which I will share on your WhatsApp so that you can do it at your own, right? And then you can mark the answer, right? So we are not starting risk and uncertainty today. Even we did the decision making part, this one, but we are not doing maximum because we are not left with enough time. So we will continue with the regular mm, schedule, right? Regular schedule is, let me try to, I cannot open my WhatsApp on tablet, but let me try to recall what we have identified. On 10th of August, same time, we will do variances, transfer pricing, CVP, and budgeting, right? So let's see if we can cover variances, transfer pricing, CVP, and budgeting all on 10th. If in case we won't be able to do that, we will keep one more class on 12th of August, 12th or 13th of August. So we will do the remaining part, all right? And then I will send you guys a mock paper, right? We are supposed to do the mock paper because we already did variances and performance measurement in the regular sessions. So um, try to solve that mock paper. I will send you answer of A and B, section A and section B, because those are the multiple choice questions. However, you are supposed to share your answer for section C with me so that I can check and I will give you my feedback, right? So that's basically how we are going to do that. So hopefully I will share the mock paper with you guys by 15th of August, right? So you can take 5 days to finish your syllabus and do it, and then share your answers with me. All right. Is there any comment? You would like to share anything? Okay. So the next session will be on 10th of August, same time. All right. Till then, take care. Bye bye. Yes. Yes, you're saying something?
No, no, I'm not saying something. I'm saying bye.
Oh, sorry, sorry, sorry.
Have a
Bye.
good day.
Good day.
Okay, then.